Today we completed a lab called Endothermic and Exothermic Reactions. In this activity, you will see if endothermic and exothermic reactions have an effect on temperature. The big idea is it takes energy to break bonds, and energy is released when bonds are formed. Directions for reaction 1. Pour 20 milliliters of vinegar into a beaker. So you have a beaker, a cup labeled vinegar, and you're going to pour the vinegar into the beaker. Then it says place the thermometer in the vinegar beaker. Make sure that it doesn't tip over. I'm going to put the thermometer in to the beaker. Then it says feel where the beaker, what is the temperature of the vinegar? So I need to wait a little bit for the temperature to read. And then it says feel the beaker where the vinegar is and how would you describe the temperature? So the temperature so far is about 21 degrees Celsius. 21 degrees Celsius. And it feels a little bit cool. Maybe room temperature or a little bit cool to the touch. So 21 degrees Celsius, and it feels a little bit cool. While the thermometer is in the vinegar, pour the baking soda into the vinegar. Observe the temperature change on the thermometer. What is happening? So I have some baking soda. I'm going to add the baking soda to the beaker and see what happens. So right now I've got my temperature is at 21 degrees. I'm going to watch what happens. Okay, so first thing I notice is that it bubbles and fizzes, makes a gas. And as I watch what happens to the thermometer, I actually see that the temperature is going down. And if I feel the beaker where the reaction's happening, it feels cold. So the temperature is now about 15 degrees Celsius. And it feels cold. Okay, so on my lab worksheet, I can write that the temperature decreased. The temperature decreased, and it feels cold. So the temperature decreased down to 15 degrees Celsius, and it feels cold. Describe what you see happening in the beaker. Well, I saw bubbles form. The main thing. Doesn't really look like anything else changed. I mostly just see that it looks like there's a little bit of baking soda left. So what I saw happening was bubbles forming or gas forming. What was the lowest temperature reached? It hasn't gone down any lower. So 15 degrees Celsius is the lowest. 15 degrees Celsius. Is this endothermic or exothermic? So answer if it is endothermic or exothermic, and how do you know? Then you're going to label which side has more and less energy. So if you look at the endothermic and exothermic energy graphs that we did in our notes, you should be able to figure out which side has more and less energy. Is it that does the reactants have less or more energy, and does products have less or more energy? Does this reaction absorb or release energy? And this question is asking, how would you explain the energy in the reaction? So you could say which side has more or less energy, and was the energy being absorbed or released? This question doesn't really make sense about the arrows because I changed it actually. So just explain about what's happening with the energy. Okay. So if you need to pause the video while you finish answering those questions, you may pause the video. And then I'm going to move on to reaction 2. Okay, so reaction 2, it says pour 20 milliliters of a baking soda solution in a beaker. So I have my baking soda solution already. I'm going to just kind of stir it up a little bit actually, because baking soda tends to settle. Okay, so I pour baking soda into the beaker. It says clean off the thermometer. Then put the thermometer into the baking soda solution to see what the temperature is. It's been sitting out at room temperature, so it should be around 20 degrees. It says about 20.5 degrees, 20 and half a degree, maybe 21, say 21 degrees. So number 3, what is the temperature? 21 degrees Celsius. Feel the beaker where the solution is. How would you describe the temperature? Feels a little bit cool. You know, 20 degrees Celsius is cooler than my body temperature, so it feels a little bit cool. Then number 5, while the temperature is in the solution, add all of the calcium chloride into the solution. Okay. Oh, it took a second to get started. Oh, there we go. And if I watch what's happening with the thermometer, I see that that temperature is going up quite a bit. It's up to almost 30 degrees. I'm trying not to touch the thermometer too much because I don't want to measure my body temperature, but 31 degrees. Ooh, and it feels warm. So if I touch the beaker where the reaction is, it feels warm. It's like actually really warm. So it's 31 degrees and it's really warm. This like that so it doesn't fall over. Okay. Okay, so observe the temperature change. What is happening? The temperature is going up or increasing. I would describe it as being warm. What do you see happening? So it bubbled and fizzed, it made gas. And then also I noticed that it looks white now. It looks like milky white. So let's say that it bubbled and temperature change. Then it says, what was the highest temperature reached during the reaction? Oh, it's still going up actually. And so now it says it is at 34 degrees Celsius. So on number 9, I'm gonna write that it is 34 degrees Celsius. Is this an endothermic or an exothermic reaction? And how do you know? And then this part is the same as the other side. You're gonna look at the energy graphs for endothermic and exothermic reactions, and you're gonna use those to figure out in an endothermic or an exothermic reaction, which side has more energy, the products or the reactants. And then it says, does this reaction absorb or release energy? And then again, question 13, you're just explaining which side has more or less energy, and is it releasing or absorbing the energy? Okay. If you have any questions about this lab, feel free to email your teacher.